All right. Okay, so we added to our table of contents. Line G should be the density foldable, and that goes on page 16. You probably already have it there. Proofs is the paper we have right now, goes on page 18. I would not glue it till after we fill it in, though. So it has overnight to dry. We may or may not finish the foldable in class today, but we should get most of it done.
So where does the
That is just practice, so it didn't go anywhere. The density foldable. And that was in hashtag 105. Remember, there's a video, and there was a foldable. You may or may not have glued it. I told you to glue it, but sometimes you guys don't listen to me. All right, ready to start on the foldable? You got your table of contents filled in? Hide your phones, lock them babies up, and let's go to the front of the foldable. Let's go to the front of the foldable. Flip to the front. Now we have been actually doing kind of like proofs for the last 3 days. So Friday we did proofs just with algebra problems, and then on Monday and Tuesday and Wednesday, I guess that's 4 days, Monday, Tuesday, Wednesday, we did different kinds of proofs. Now some of them were specific, like just prove one thing, and other ones were kind of open so that you practice proving a lot of stuff and looking up stuff on your pink sheet. Okie dokie? So obviously you should always, when we're doing proofs for the first couple weeks, you should have your pink sheet handy so you make sure you are pulling from your pink sheet. Because nothing on your reasons column should be something that's not on your pink sheet, right? So make sure it's on your pink sheet and you know that it is. Okay, so here is the proof writing process. So you might want to have some colored pencils to highlight some important stuff. These are the steps that we're going to go through when we do a proof. Remember, if nothing is in color, what's going to happen when you go to study for your midterm exam, like in December, you're going to look at a page and everything's going to be black and white. And you're going to be like, I got to study the whole thing because nothing pops out at me. Whereas if you have things color-coded, you can just glance at them and remember the key ideas that are most important, right? So it saves you time later if you put in the time now for good notes. Okay, so the proof process has basically 4 steps. Step number 1, 2, 3, and 4. And let's talk about what those actually mean. So, step number 1 says to draw a diagram, if they didn't give you one, and mark up the diagram. What does marking up the diagram mean? Label stuff. So we're gonna, sometimes you have to draw it, and sometimes you just have to mark it up. Depends on it. We've had problems that we didn't have a drawing and we had to make a drawing, right? So that means you're gonna label stuff. You might wanna have some colors, so that way you try to figure out what's going on in the picture. And I think that's a good strategy for every single math problem in the entire world, right? Okay, step number 2. They have step number 2 as to state the givens. That means whatever they gave you, and remember the givens can be words, they could be words, or in a picture, right? So sometimes they'll just say a bunch of stuff, and those could be your givens, or sometimes they'll just give you a diagram that's got some stuff labeled in it so you can get some givens. Like when we had that little right triangle, we knew it was a right angle, even though they didn't actually say words that said that. Okay, step number 3. Step number 3 is our end goal. Basically, what are they asking us to prove? So this is our end goal, and it's basically what do we need to prove? Prove or find, right? Because sometimes they'll be like, find the measure of angle 3. So that's something we have to find. Or they might say, prove segment AB is congruent to segment FG. And so that's what our goal is going to be. Remember, we did a bunch of them where we didn't really have a goal. We were just doing everything. But most of the time on a proof, they'll have you just be doing one thing. You got to be looking for one thing. And the last step we have here is you got to kind of make a plan on how to get there, right? You want to have a plan. Like, how do we prove that? How can we prove that? How can we prove that? So, like if you were a lawyer, your whole job is to prove something, right? Now, you could probably say a lot of stuff about a person, right? But if it has nothing to do with proving your case, then you're probably not going to put it out there. So just because you have a picture and you could say a bunch of stuff about it, don't waste your time saying stuff that is not even going to get you to the end goal. That's why you kind of need to have a plan, so that way you know what direction you're going to go to, so you just don't say a bunch of 50 random things about a picture, right? Otherwise, you'll end up with like 12 things like we were ending up with when we were doing the random ones. Okay, you cool on the process? All right, so here's an example of a proof that's pretty much done. So let's look at this proof that's pretty much done. So, you can't see my steps, but you can see the steps, right? So what does the very first step say they should do with this? Draw a picture, mark it up, label it. Okay, so let's see what they gave us. You're going to need some colors because this is a small picture, and if you just write in pencil on it, you're not going to be able to see what's going on. Okay, so what is our first given? Yeah, and you can't really see it, but this is actually a ray. Let's put a little arrow on that. There is an arrow ray there, even though you can't really see it. The font is kind of small. What is a ray again? A ray has one fixed point. Bam. Fixed means it's stuck there. And then it's all the points that go in one direction, right? So it could be a point here, going to the right, left, up, down, but it has one fixed point and then all the little points all connected forever in one direction. So we do have a ray, FD. Let's find him in our picture. You find him? I'm doing purple, so I'm going to go ahead and underline this in purple, and I'll do this part in purple, and then I'll switch my colors for the next one. Okay, does everyone see FD? Starts at F and goes towards D forever. The fixed point is F, and then it is all the points forever and ever in a line in the direction of D, correct? Okay, and it bisects. Bless you. What does bisect mean? What? One more time. It does go through, but it goes through like exactly how? Bisect is going to form what? Two what? Two equal pieces. So make sure when you see bisect, you might just want to put it up. It's going to have two equal pieces. And it depends on what you bisect. If I bisect a steak, I get two equal steaks, right? If I bisect a candy bar, I get two equal candy bars. If I bisect an angle, what do I get? Two equal angles. If I bisect a segment, what do I get? Two equal segments. So think about what you're bisecting, because all you get is two of those exact same thing, but obviously half the size, right? So I'm going to be bisecting this angle, correct? So find angle E to F to C. So I'm going to use my same purple. Where's E to F to C? Starts at E, goes to F, goes to C. Do you all see him? So you see the angle that's being bisected, cut into two equal angles. Do you see the two equal angles in the picture? Yeah, they're right next to each other, right? Let's mark them equal, okay? So when you mark angles congruent, you put an arc on them. You basically have matching arcs. So you could have arcs with a little tick on them, an arc with 2 little tickies on them, double arcs, triple arcs, as long as your arcs are matchy. Okay, so let's do this one. Let's make an arc with a single tick on it. And then an arc with a single tick on it. So someone looks at our picture and they see those matchy arcs with the matchy tickies. Then they know that they're congruent. Okay, so I basically filled in my diagram for my first given, right? So let's go ahead to our second given. I'm going to get a new color. I'll just go orange. Get yourself a new color, because some of these are going to be overlapping. So if you do all the same color, it's not going to work out for you. Okay, what's our next one? That is array. What's array? A fixed point with all the points going in one direction in a line. This is array. That is an arrow on top. You find FC. Did you find him? F to C going forever, right? Bisects angle DFB. Where's DFB? Start at D to F to B. That's this orange guy right here, D to F to B. I'm bisecting an angle, so I get 2 equal angles. Do you see the 2 equal angles I get? You see them? Now I have to make a different kind of arc, right? I can't use the arc with a single tick because that's what I used last time. So I'm just going to do, just to mix it up, I'll do a double arc. So someone can look at that and be like, oh, those double arcs are congruent. Now when you do segments and have them congruent, you can only do tickies, but with the arcs you can do like double arcs, triple arcs, an arc with one single tick on it, an arc with 2 ticks on it. All right, those are all our givens. So our diagram is marked up, correct? Yeah? Now some people like to go to the, what step are we on anyways? We just did 1, right? We just did step 1. Do you want to check out step 2 first? Let's go ahead and put, just for the sake of this, this junk right here is our step 1, right? Step 1 is marking up our picture or drawing our picture and labeling their stuff. That's step 1. Step 2 said what? What did step 2 say? State the given information. Okay, so let's look, because they already did this proof for us. Do you see how they stated the given information? Look right here. This right here is step 2. This is their step 2, which are the givens, right? Now, some people love to put all the givens on the very first line, and you're allowed to do that. Sometimes people put just the givens they're about to use, but sometimes there'll be 6 givens, you know what I mean? And so sometimes they'll put just what thing they're going to use. There's no rule that says they have on the very first step. You can put some on the first step to get you started, and then maybe add in other ones as you go, as you need them. But a lot of people do like to just throw them in the first step, and that's up to you. I sometimes do, I sometimes don't. But they chose to put all the givens right there. So that is their step 2. Step 3, what's their step 3? What's step 3? What is our end goal? Look at this. What is our end goal in this problem? This right here, this is our step 3. This is our end goal. Step 3, end goal. That right there is our end goal. We want to prove that. And so I'm going to look at my picture and see where those are. Okay, so we want to prove that EFD, so that's E to F to D. That's this angle right here. We want to prove that that angle is congruent to CFB. CFB, that's this one. So That's what we want to prove. Now, I'm not going to put matching arcs on those because I didn't prove those congruent yet, right? So I'm just putting a question mark just so I can see, like, those are the two angles. And then the last step is you need to make a plan. So let's look at this picture. Do you think that this has to be true or not? Just look up here for a second. We have these two purple ones congruent, correct? And then we have these two orange ones congruent. Do you think that these two green question marks have to be congruent to each other? Here's a strategy is to make up a number. Okay, so let's look at this top angle here. This angle right here. How estimate the measure of that angle? How many degrees do you think that angle is? 50? Is that a decent estimate? Whatever. If we said this is 50. Okay, if we said that was 50, he has to match this other purple guy, right? So what's this guy have to be? 50. What's this bottom angle have to be? Why does he also have to be 50? Because it's congruent to the two orange guys have to match. So is that going to be true no matter what number you pick? So if you knew this one has to be the same as that one, and that one has to be the same as that one, so does that mean these two are always going to be the same? Okay, so it does make sense that we can probably prove that, right? So that's what they mean by coming up with a plan. That means look at it and see if you could somehow make it make sense. And you can put fake numbers in, just get rid of them after, and don't use them in your proof. But a lot of times I put fake numbers in to see if I'm like, oh yeah, it has to work out. Like no matter what number it is, it's gonna work out, right? So that's what they did when they have this plan. Okay? So does everyone understand how you do step 4? You have to think through a plan before you start writing a whole bunch of gibberish in here. You know what I mean? Okay, so you can look through their proof. They have completed this proof for you. You can look through that step, but what all we wanted to use that for really was to see how they did the 4-step process. Okie dokie? So let's just go ahead and answer the questions underneath it. And basically about the 4-step process. But this is actually good proof that I've seen that show up on stuff. So you definitely probably want to look over it on your own. Okay? So let's go ahead to the questions underneath. And you're going to fill these out. The first question is, what was the given information? What was the given information? Yeah, it's this stuff right here. So hurry up and write this stuff right here. These were the givens. This line and this line. Just go ahead and write them down below. I'm not going to write them. You can write them. Write your givens. Okay, and the next line. What's the next line asking for? What should be marked in the diagram? Okay, so you marked it up, right? Okay, so write down what you marked up. Because you probably put 2 different colors up on the top. So write down what you marked up. Write down on that line all the stuff you marked up in your picture. Put your givens right there. Those guys, and then put down whatever you had to mark up. All right, the next line, what's it say? What was the conjecture to be proved? Does anyone know what a conjecture is? Or can you figure out what it is based on the context of this question? Huh? Yeah, it's basically like a theory or an idea that you want to prove. So this is like some kind of theory that they wanted you to prove. So some theory or idea that's not yet proven, right? Okay, so what was it that they wanted you to prove? Yep, they wanted you to prove this. What we circled here in green. Or I circled it in green. I don't know what color you did. So that's what they want you to prove. That's their theory. They think that those things are congruent. And we also think that they are. And then the last question is, what titles should be on the top of the two columns? Does anyone remember what titles go at the top of the two columns? Let's go ahead and put them up there too. Do you remember? Second one was reasons, yep. So let's throw that up on top. Anyone remember the first one? Statements. Statements and reasons. So statements. Statements and reasons. And I know when we were doing some practice ones, we weren't taking the time to put statements and reasons, those words up at the top, and that was because we didn't really have a whole lot of space. But technically, they'll put them up there. All right. Are you guys cool on the front? Okay, so let's go ahead and crank through some on the inside. Beep, 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 beep. All right, here we go. And remember that these take about like 8 lines to do, so don't write super big. Actually, this one takes about 8 lines. I think the next one only takes about 4 or 5 or something. Okay, so let's start off with our headings. So what are the headings we're going to put on this guide? Statements and reasons. So let's go ahead and set this up. Don't write big. Statements and reasons. Hi.
Hey.
What's up?
You have Mr. Eubanks.
Yeah. Mr. Eubanks, you are needed in the hallway. All right. So, what did step 1 of our proof process say? What are we supposed to do first? Flip to the front. What did it say we're supposed to do? Make a diagram. Now, does it make sense to make a diagram for this problem? No. This is just an algebra problem, so we don't need a diagram. Step 2. What do we want to do? Do our givens. Okay, what did they give us? They gave us the equation. So step 1 is just 6x minus 9, oopsie, equals 13x minus 16. And what we put over there for our reason? Given, alrighty. All right. Go ahead, do your first step. What are you gonna do? You gotta solve this, baby. I'm gonna put Mr. Squiggly down the middle. Love Mr. Squiggly. Okay? Tell me the first thing to do. Huh? Huh? I have X's on both sides, so I'm going to save myself some grief and get rid of one of those first. Which? Why? You like negatives? I don't. I'm going to get rid of the 6 because I don't like negatives. If you get rid of the 13, you're setting yourself up with negatives right off the bat. You can still get the right answer, but... so tell me why am I allowed to subtract 6x from both sides? What's on the pink paper that says you're allowed to? What? Subtraction property of equality. Awesome. Number 2 is subtraction property of equality. And I'll abbreviate subtract prop with an equal sign. Subtraction property of equality. Remember, everything on the right better be on the pink sheet. The word given is even on the pink sheet. It's the very first thing up in the top left corner. Okay, step 3, what does that look like? Come on, you all passed algebra. Let's go. What do we got here? Is it a 9 or a negative 9? It's a negative 9. Equals, what do we have here? 7x minus 16. Okie dokie. And what did I just do? I just simplified. Now you're going to notice sometimes they'll leave out the simplify step because they'll actually just do the math in their head. You know what I mean? It's like they will skip over putting minus 6x on both sides and just in their head write minus 6x up and just write this answer, and then you would know they just subtracted from both sides. Remember, if someone has worked out a problem, you always go off to the side and work out the problem yourself, and then ask yourself what they did. All right, next step. Step 4.
I just put add 16 on both sides.
Okay, and what property is that? Addition property of equality. Remember, if you're doing it to both sides, it's the property of equality. You're doing it equally on both sides, right? And what does step 5 look like then? 7 equals 7x. And you could just call that simplify. All right, then what? Divide both sides by 7. And since you're doing it on both sides, that's going to be your division property of equality. Division property of equality. And I get what? I get 1 equals x. That's my line 7. And that was just simplify. Are we done? Yeah, look back up at what they actually wanted you to prove. What did they want you to prove? No sleepy time. They wanted you to prove x is equal to 1. Did you actually prove that yet? Technically, you didn't. You proved that 1 equals x. Now you know that you can turn things around on an equal sign, and the opposite is true, right? And now that is actually a property that you learned probably back in 5th or 6th grade. That if A equals B, then B equals A. And that is the symmetric property. So let's put symmetric property at the end. So that means that x does have to equal 1. And that's our symmetric property. Now you guys know some stuff about symmetry. You know some stuff about symmetry. Basically samesies on both sides. And do anything in art. And we should probably put a note on this property just so we know that we talked about this. Maybe let's put a note by this so that way you see it in your notes. You might want to color it. Symmetric property is basically if A equals B, then B equals A. So it's basically just turning it around, right? So at the end, if you need to turn it around and you need a reason, and that is on your pink sheet. Find it on the pink sheet. I think it's way down on the left. Let's find it and put a dot by it so we know where he is. Somebody find it on the pink sheet. Tell me where it is. What? First column at the bottom. Put a little dot by him so you know where he is. Remember, for your first test on your proofs, you're going to get to use your pink sheet, so it's going to be easier to find stuff that we use all the time if you've got some little colored stars or dots or something by them. All right, cool on that proof? Okay, let's go to the next one. Okay, we're going to write a 2-column proof on this one. So, here, grab a We're going to write a 2-column proof on this. So it says, what's our first step? Step 1 of the process is what? That's step 2. Yeah, let's color, label, find what we have, okay? Mark up our picture. Okay, so we're given that segment AB. Okay, so you see this little congruent sign? You see it has a dot on the top? Don't worry about the dot. There's some fonts when you're typing, the dot just pops up on top, so just ignore the dot if you see it. It's just the weird font, you know? Okay, so AB, segment AB is congruent to segment CD. So let's find those in our picture and mark them. Where's AB at? It's right here. It's that little green piece. Is congruent to CD. That's this other green piece over here. And notice they have put matching tick marks on it for you already, so that way when you looked at it, you knew that they were congruent. Remember, you could put like single tick marks or double tick marks. If you see them matching ticks, then you know that those are congruent pieces. That's all they give us, right? Good? Okay, so step 1 was to mark up our picture. What did they say step 2 was? That was to state our givens. So let's go ahead and start our proof and state our givens. Okay, so we need what at the top of the column? Statement. Why? Why, board? Why are you doing that? It's weird stuff. Statement. Oh, and over here, let's put our reasons. Okay, so our first statement is that segment AB, remember if the bar's on top, you read it, segment AB is congruent to, squigglies with equals, segment CD, and that is given. The paper? Yeah. I assumed. Okay, that's our given, right? Okay, what's, we did step 1, we did step 2. What's step 3? Flip to the front if you forgot. What's step 3? What's our end goal? Okay, so let's look at our end goal, because we can't come up with a plan if we don't know what our end goal is. So our end goal is, I'm going to pick a new color. This right here is our end goal. So our end goal is we want to prove that the length of or measure of AC, you see how there's no bar on the top, and that way you read it the measure of or length of. The measure of AC we want to be equal to the measure of BD. So let's find AC in this picture. AC goes where? From here to here. That's one of them. We want to prove that that's the same length as from B to D. So that's from here to here. We want to prove that those two orange pieces are the same length. Okay, that was step 3. That's what their conjecture, what we want to prove. Now step 4 is to come up with a plan, which means we need to look at this picture, maybe make some fake numbers if it helps us, to figure out if we think those two pieces have to be congruent. Anyone have any thoughts? We know this part is equal to that part, but we're adding this little chunk onto both of those, right? So does it make sense that you think that they have to be the same length? You say yes. Why?
Well, looking at the diagram, it shows that both, I can give like a little gander and it looks like both pieces are about the same length.
Well, you don't have to gander about it. This piece and this piece are the same length because they told us they are. The only thing in question is this middle piece, right? We don't know anything about this middle piece. But what's true about that middle piece? Isn't it being added to this piece and that piece? So should we end up with two equal length pieces? And watch me make some fake numbers, because fake numbers sometimes make you things make sense. Don't be on your phone. Give me a fake number for the length of this. 15. Fake number here. So this is also 15, right? right? Give me a fake number for the middle. 30? Sure. Doesn't really matter. Okay. So what is the length of this top orange guy? 45. What is the length of this bottom orange guy? 45. So would that be true no matter what number you picked? Okay, so it does make sense. We're going to have to try to prove it in some way. Okay, and I'm going to erase those fake numbers because they're made up. But fake numbers sometimes help you visualize something and see if it makes sense to be true. Okay, so step 2. So here's what we want to do. Now, this one thing I like to do is look at what we want to prove. We want to prove, and we want to have it to be an equal sign, right? That just moved, didn't it? Possessed. We want it to be an equal sign. So I'm going to go ahead and change this line to an equal sign. Is it true that the measure of AB is equal to the measure of CD? Is this true? How do you know this is true? Because of the definition of congruent. So we have the definition of congruent. So number 2 is going to be definition of congruent. Whenever you have, if you want to switch between equals and congruent, use a definition of congruent. So you might want to put a note. So if you want to go from equal to congruent, or vice versa, that's usually the reason you're going to be using. Okay? Because if you know something's equal, then you know it's congruent. If you know something's congruent, then you know it's equal. Okay. So we have these 2 green pieces, right? What are we adding on to both of those green pieces? We took this. What do we add on to it? That piece, right? And on this side, what do we add on to it? That piece. So for both situations, we're adding BC to both of them, aren't we? So I'm going to add BC to both sides of this. I'm going to add BC. If I do it to this side, am I allowed to do it to this side?
Yeah.
And that's totally legal, isn't it? Okay. And what property is that called when I add the same thing to both sides? Addition property of equality. It doesn't matter that it's not an actual number, right? Actually, it is officially a number because it's the length of BC. We just don't know what that number is. So this is the addition property of equality. Addition property of equality. Now we're about to do some weird math by looking at a picture. Because we have to add up some segments. So let's look. Watch me do a color. Just watch me do this for a second because then it's going to make sense. I'll pick a color I didn't use yet. Blue. Okay. If I add up AB plus BC, let's go to the picture. AB is right here. Plus BC is right here. What piece do I end up with? Don't I end up with AC? So if I add these 2 up, I actually get AC. And you have to do that by looking at the picture, right? Okay, do the other piece. Do this other side. So look at the picture, find CD, and add it. Do you need them again? And add it to BC. What picture, what piece do you think you get? You can do it in a color on your pick. What? CD plus BC is BD, isn't it? Is that what you guys got? And who said we're allowed to add 2 little segments to get a big segment? What property does that have your king paper? Go ahead.
Segment addition postulate.
You got it. Abbreviated all of those. And isn't that exactly what we wanted to prove? Looky, looky. Done. And we're gonna do the other two tomorrow, but I do want you to glue this right now in your notebook so he does not get lost. What page? 18. Thank you. Do you want to do some proofs? Sure. Page 18. Blue on 18. Blue on, you grab it.